Hey guys.
All right, using graphs to relate two quantities.
So we're representing mathematical situations or relationships using a graph.
That is our objective.
Boom.
Got it. Hold on to your seat. Okay, so the graphs below relate the height of water to the volume. So we want to know which one of these graphs relates to which
Picture.
There we go.
Cylinder.
We're like, well, they're not all cylinders.
Well, yeah.
Container.
Containers, good.
Container.
And we're talking about, are we filling it up? Or
We're filling it up with water.
Okay.
So if I have a glass of water and I'm filling it up, which graph relates to me filling that up?
Okay. So are we doing it right now?
Yeah.
Okay, so let's look at the first one. I can see that the very first graph, the height is increasing steadily.
Yep.
And then the height is increasing steadily. The volume obviously is increasing steadily, but then it kind of tapers off a little bit. And so
it's almost like it got bigger, so it had to fill up. The height didn't grow,
but you're right.
But the volume
grew. So there was more water in there.
Right.
So I'm guessing that goes with that one over there.
Perfect.
Because as I fill that up, it's gonna
gradually went up here.
Yeah, the cylinder part's gonna fill up, and then the volume is going to increase because it opens up like this.
Right.
But the height didn't get as high.
Got it.
So hopefully that makes sense to you.
Okay.
This one.
So it's not very tall. I can see that's the shortest of them all.
Well, yeah, and that's cool. Let's compare the two that are left to the two pictures that are left.
Okay.
One's short and fat, one's tall and skinny.
I know where the short and fat goes.
Right.
Here.
Because, yeah, the height is going to increase to a small amount, but the volume's also increasing. Right. The skinny one.
Well, it's super high.
Right. And your height and your volume increases quickly when you have a little tiny skinny thing. I know, I'm certain that you guys have seen that in science when you fill up the graduated cylinders.
Yep.
So there you have it. It's that easy, folks. So, okay, now we're looking at an air balloon.
Yeah.
Should we ask this question first?
Yeah.
How can you analyze the relationship in a graph? So,
read the titles.
Good.
So read all the information that's given. So it says read the titles, read the axis, and they'll tell you which variables are related. So the graph itself represents the relationship as the variables change, just like we talked about in the last one. You had the volume and the height. In this one, we have time and volume.
Okay.
Variables are things that are subject to change.
There you go.
Words of wisdom.
Farr.
Mr. Farr knows what's that.
You got it.
So, and then in this case, we're talking about volume and time as it relates to air in a balloon.
Right. Okay. So the graph below shows the volume of air in a balloon as you blow it up until it pops.
Ooh. It's always a scary
What are the variables? Describe how the variables are related at various points on the graph.
Okay.
So it's asking, what are the variables? So the variables here are
time and volume.
Time and volume.
Those are my x and my y.
Yep. So I can say x equals time. And yes, you have to do this in your homework. You have to be specific.
Yeah, you have to tell us which one is x and which one is y. It's super, super important. If you ask Bennett or G, they'll tell you the same thing.
Yep.
In your science class, it's important to know which one is x, which one is y.
You got it.
Okay.
So which one was here? The volumes are?
Volume and time.
There you go.
The volume increases each time you blow. Well, duh and a half.
So you blow and then you take a breath, right?
But, okay, and so when you're breathing, time doesn't stop.
Right.
But the air going in the balloon does. So air goes like this, but time keeps going.
And yeah, just doesn't stop.
But air doesn't fill up.
So that's what these plateau sections are, is when you stop to, and then you go again. Okay?
Yeah.
And then what happens here, Rich?
Well, okay, so I blow, 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 and then it's too big. Everything stops, time stops, the whole relationship is over because the balloon has popped.
You got it. So can you tell if the balloon popped in the middle of a breath or in the middle of me blowing into the balloon?
Well, based on what the graph looks like, it's increasing and pops.
There you go.
So it means I'm blowing in and it pops, which would be very, very frightening to have happen.
Or hilarious if it's bubble gum.
That's true. That's true. All right. Okay. Analyzing a graph. What are the variables in each graph?
Okay.
So this one.
So x is
time.
Y is
length.
So this doesn't have anything besides the graph for us. It just has a graph, it has a title, and the axes are labeled.
And now we've got to figure out what in the world is going on with apparently a board.
So a board length. Okay. So I'm thinking of like a 2x4, and over time, it's weird, I was thinking of a 2x6. Okay, we'll go with 2x5.
Okay.
And then over time, it looks like it gets shorter.
Because the length is coming down.
Right.
But what I notice is that it's not going, it's not a diagonal. Well, it's duh and a half. The board is not going to, it's not going to shrink.
Right.
How do you get a board to decrease in length? You make a cut. So it looks like,
Mass strain.
yeah, the board is this long, they cut it. Now it's this long for a certain amount of time, they cut it.
Yep.
Keep going.
So time continues, then we just chop it down.
Mm-hmm. Now, does the board ever disappear? Does the board
No.
ever get down to 0 length?
I mean, it could, but
It
shouldn't.
It doesn't
Yeah.
here.
It should, yeah. So right here, it stops at whatever height this is.
Mhm.
We don't know. It doesn't tell us that.
Mm-mm.
Okay. So again, it says describe how the variables are related. So we did it very lengthy for you, but it says the length of the board remains constant for a time before another piece is cut off.
You can be wordy if you really need to.
Yeah.
All right, so let's look at B. We've got minutes of calls
Mm-hmm.
and the cost, and this entire situation is about cell phone use during the month of June.
You got it?
So X is minutes, Y is cost, and
So it looks like you get, for a certain cost, you get this many minutes.
got it. And then
After that, you pay per minute.
some sort of amount of money.
Right. And that's irrelevant because it gives us no
Right.
reference of
So ultimately,
money here.
the time remains constant. So I have a certain amount that I pay at the beginning, and then I start paying a per minute charge because
Got
it's increasing there.
Okay. Matching a table and a graph. Here you go. We are given 3 different scatter plots here. We just have to apply which one is our answer. So here is what we're given from the table. Then we're going to choose A, choose B, or choose C.
Okay. Oh, so this is a multiple choice. This is not a
Yep.
answer.
Nope.
3 answers.
Yep, so it's matching a table and a graph.
Okay, so we've got,
So the table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used.
okay.
Which graph could represent the data shown in the table?
Okay, so I'm not just thinking, okay, this is how I use sunscreen. I have to actually look at what's going on in the
Exactly.
table.
Yep.
So I know the first time there was 0 uses and there was 5 ounces in the can.
Yeah, and it looks like all of them start right there.
Mm-hmm.
So that part doesn't really help me.
Right. Well, and I also know that as I use sunscreen, or if it's the spray kind, it's going to decrease. I also see that each of these are decreasing,
Okay,
so I still
perfect.
can't
Mhm.
eliminate any.
Right.
I now see that it goes down by 0.2 every time.
Okay.
So it looks like
if I
it-
wanted to just mark this, I don't have to, but
That's
just
a good idea. It goes
Yeah.
down, and it's that much every time.
Okay.
So that's a constant rate of change.
Right.
So it's not like one time they used 1,000 globs of it for like an adult, and
Right.
then they used a teeny time for like a baby.
Right. So I see that this is a constant rate of change.
It is. I also see that C is a constant rate of change.
Okay, so B's out.
B's out because that is not a constant rate of change when it curves.
Okay, so when I look at A, since that's what I picked,
Mm-hmm.
I see that I start here and then I end with my bottles empty.
Right. After 3 uses, or 4 uses, or 3.
Yeah, it's probably not right.
I don't think
Because
so.
it tells me,
At the end, I should have 4.4 ounces left, and I
Right.
started with 5. That's not very much
Right.
gone.
so
C.
C is our answer.
Mm-hmm.
Got it.
Oh, look at that little guy.
Look at him. Answer C.
Ooh, those are teeny graphs. Are they bigger on? They're bigger on the notes.
Sure.
I hope so.
Yeah.
No, if not, it's fine.
Okay, table shows number of customers at a car wash after 1, 2, 3, and 4 days of its grand opening. Which table could represent the data shown in the table? So, grand opening a car wash. First day, there's 61 customers.
Mm-hmm.
Second day, 125 customers. Third day, 177 customers. Fourth day, 242.
They've
That's total customers.
Okay. Oh, it's a running total.
It looks like it.
Okay.
Yeah.
So they're increasing. Are they increasing each day or not?
Yep, it's increasing.
Okay. Well, unless this is a running total,
Well, it's still increasing.
that's true. I guess the total number of customers that they have is increasing.
Right.
Got it. Okay.
Right.
So we need to look and so let's
Well, you just said it's increasing,
Yeah,
so
so-
it's not D.
or C.
Whoa.
Because
Correct.
C and D are both going down.
Okay.
Okay. So now let's look at the rate of change. So from 125, from the first day, excuse me, that's wrong. 125 minus 61. I got 64. So from day 1 to day 2, they increased it. They had 64 more people show up.
Okay.
From the next day, they had 52 people show up.
So you're just taking 125 minus 61 to get this.
Right, to see how
177 minus 125.
much they increase each day. And then the last one, 242 minus 177, I got 65. So the amount of change is super close between 1 and 2 and 3 and 4 and less between 2 and 3.
Right.
So I'm not looking for a straight line
Linear.
up.
Right.
And I'm not looking for a curve because a curve would indicate increase by a lot and then keep increasing by less and less each time.
Right.
So if I look at my 2 graphs that are left, B increases but by less and less each time because the arch, what's the word, flattens out.
Yep.
So I'm going to go with A.
Okay.
And I think we're right. Again, you can see the large jump for the first between the first 2 dots and the last 2 dots, and a smaller jump between those middle ones.
And this was about 65 as well, and this was 65, and it's kind of about the same
They're about
distance.
the same distance, yeah. I like this. This is fun.
Okay, sketching a graph. Now this is where
It's sketchy.
it is sketchy because all answers will be a little different.
Right.
It's all good. Okay, so a rocket model rises quickly and then slows to a stop as it burns fuel, as its fuel burns out.
Okay.
It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What sketch of the graph could represent the height of the rocket during its flight?
Let me use my arms with what's happening.
Okay.
The rocket shoots off,
Okay,
and then
that's shown here.
and then it stops rising, starts to fall because it burns out, and then the parachute opens, and then obviously once a parachute is there, you kind of float down. Okay, got it. Oh, and it's all written right there.
That's right there.
Okay, so what are we doing now?
Well, it wanted you to do this.
Oh, it wanted me to write that
Well,
to
this
make
is your
that.
example.
Okay.
So now we'll move on to actually doing it.
Okay, so now Malcolm is jogging on a treadmill. Holy moly.
Yeah. Go, Malcolm.
Okay, it's your birthday.
Yeah.
He gradually increases his speed until he reaches a certain level. So I know increasing gradually is going up a little bit, okay? And then he's going to reach a certain level. And then it says he jogs at this level for several minutes. Then he slows to a stop and stretches. So his speed would be 0 at that point, right?
Right.
Because he's not
Right,
running
he's
at
not on
all. He's stopping.
Right.
But time is
will keep
happening.
moving.
Okay, and then, so he stretches. After this, he increases to a speed that is slightly lower than before and jogs at this speed for a short while slowing to a stop again. Make a sketch.
Okay.
So,
Well, how do we get started?
let's identify the variables.
Okay.
Height and time.
Already given for you. You're welcome.
Or speed, I guess is what
Yeah.
we've got. Okay, now we're going to look for keywords like rises quickly, falls slowly. So the first thing I
Okay,
see,
tell me what Malcolm does.
the number 1 in the very first sentence, he gradually increases his speed until he reaches a certain level.
So would that be a steady or would it be an
No,
arc?
a gradual is gonna, it's gonna arc a little bit, don't you think?
Yeah.
Ooh, that's real pretty. Okay, so gradually, great. And then he stays at that speed for several minutes. So it's gonna go, brr. It looks like what the little printout on your treadmill, you know,
Yeah,
that little thing
it
that's
does.
on there.
Mm-hmm.
Okay, then it
Well, mine's
says,
like, you know.
oh yeah, mine goes like this. Then he jogs at the slow. Okay, then he slows to a stop and stretches. So he's not going to boom stop,
Right.
but
so
he is going to go
gradually
back
goes.
down and all the way down to where his speed is 0 because he's not running anymore.
Okay.
And he stretches for some time. So time goes, but he's not running. Cool. Then it says he increases to a speed that is slightly lower than his previous speed before stopping again. So he's going to go back up, but it's going to be lower than the first bump, and then
Slows back
before
down.
slowing down again. The end.
There you go.
Now, what if mine went way up high and then back down and then back up again? Would it be okay?
Yeah,
As
totally
long
fine.
as your 2
As
bubbles.
long as you're telling us the same thing.
Right.
I'm going to run out of room. But as long as you're telling us the same thing, it's totally fine.
Exactly.
Yeah.
Okay, love it. Okay. Oh,
Your
wow.
turn.
Okay, so do this.
Do it.
Okay, we will
2
see.
problems.
That's, yeah, and you know what? They're very easy. All right, we will see you.
On the flip side.
Bye-bye.